Please like the video and share it with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem that appeared in the CSIR National Eligibility Test held in the month of July 2024. This question is from the section Algebra, and the question is related to the concepts of the minimal polynomial of a matrix. This question is from the part C, which is a multiple select question. There can be more than one answer, and it carries 4.75 marks. The question ID is 704074. Right. The given question is, let A be a 4x4 real matrix whose minimal polynomial is x square plus x plus 1 and B is equal to A plus I4, the 4x4 identity matrix. Which of the following statements are necessarily true? We are given four options. Option 1, the minimal polynomial of B is x square plus x plus 1. Option 2, the minimal polynomial of B is x square minus x plus 1. Option 3, B cube is identity. Option 4, B cube plus I is equal to 0. Let's now discuss the solution of the problem in detail. We are given capital A 4x4 real matrix. We are given the minimal polynomial of A is x square plus x plus 1. The minimal polynomial of A is represented as m suffix a bracket x, and that is given to be x square plus x plus 1. Let us recall the definition of the minimal polynomial of a matrix. It is defined as the monic polynomial. Monic means the leading coefficient is 1. The monic polynomial, m polynomial of the smallest degree, such that ma of A is equal to 0. So the minimal polynomial is x square plus x plus 1. The minimal polynomial of A is x square plus x plus 1. Therefore, ma suffix a of A must be equal to 0. That means A satisfies that minimal polynomial. A square plus A plus I. Agreed. Now, we are given B is equal to A plus the 4x4 identity matrix. Let us now talk about option 3. B cube is equal to I. Option 4, B cube plus I is equal to 0. So we have B is equal to A plus I. So B cube will be A plus I whole cube. That will be A cube plus 3A square plus 3A plus I, because I and A commute. Therefore, this happens. And now use the fact that A square plus A plus I is equal to 0. So we take a common, write in brackets A square plus A plus I, and adjust the terms. The remaining terms will be 2A square plus 2A plus I. and we know a square plus a plus I is 0. So you are left with 2a square plus 2a plus I. And that is written as 2 times a square plus a plus I, and adjustment you have to make, and 2I has come and we have I above, therefore minus I you have to make. And this is 0, a square plus a plus I is 0, so we are left with minus I. So thus we got b cube is equal to minus I. But in option 3 it is given b cube is equal to I, therefore option 3 is not true. B cube is equal to minus I will imply b cube plus I is 0. So this is precisely option 4. Therefore option 4 is true. Option 3 is not true. Option 4 is true. Agreed. We continue the discussion in the next slide. Right. We have already seen in the last slide b cube plus I is equal to 0. We require this result. Now we go for option 1. The minimal polynomial of b is x square plus x plus 1. Option 2. The minimal polynomial of b is x square minus x plus 1. One of them is C. So now the minimal, we are given the minimal polynomial of a is x square plus x plus 1. And what are the roots of the minimal polynomial of a? They are the roots of x square plus x plus 1. That is, what are the roots of x square plus x plus 1? They are the complex cube roots of unity, that is omega and omega square. And the roots of the minimal polynomial are all the eigenvalues of a. So recall, all the eigenvalues of a are the roots of the minimal polynomial. The roots of the minimal polynomial are omega and omega square. Therefore, all the eigenvalues of a are omega and omega square. Right. If omega is an eigenvalue of a, so what will be the eigenvalue of b? That is, what will be the eigenvalue of a plus I? That will be 1 plus omega. 1 plus omega is omega minus omega square, because 1 plus omega square is equal to 0. We have b is equal to a plus I. The eigenvalues of a are omega and omega square. Therefore, the eigenvalues of b is equal to a plus I are 1 plus omega and 1 plus omega square. 1 plus omega is minus omega square, and 1 plus omega square is minus omega, because 1 plus omega square is equal to 0. So thus the eigenvalues of b are minus omega square and minus omega. Right. Now we have already had this statement. We have already proved b cube plus I is equal to 0. That is, b satisfies the polynomial x cube plus 1. So that means x cube plus 1 is an annihilating polynomial of b. Is an annihilating polynomial of b. Let us recall a property of the minimal polynomials of b. The minimal polynomial divides every annihilating polynomial of b. The minimal polynomial of b divides every annihilating polynomial of b. So therefore, the minimal polynomial of b divides x cube plus 1. So the minimal polynomial of b divides x cube plus 1 implies the minimal polynomial of b divides x plus 1 into x square minus x plus 1. This is a factorization. So this will imply a the 1. The minimal polynomial of b is x plus 1. Now one may say, sir, k times x plus 1. We need not have, because the minimal polynomial is a monic polynomial. Therefore, the coefficient will be 1 only. Or the minimal polynomial of b is x plus 1 into x square minus x plus 1. Or the minimal polynomial of b is x square minus x plus 1. Now, the minimal polynomial of b is x plus 1 if it is so. Then an eigenvalue of b will be minus 1, which is not true. The eigenvalues of b are minus omega square and minus omega. So minus 1 is not an eigenvalue of b. Therefore, it is not true. If the minimal polynomial of b is x plus 1 into x square minus x plus 1, then the eigenvalues of b will be minus 1 minus omega square, which is not true because minus 1 is not an eigenvalue of b. So therefore, the minimal polynomial of b is x square minus x plus 1. Therefore, the option 1 is not true. Why? Because the minimal polynomial is unique. It is x square minus x plus 1. Therefore, option 1 is not true. And the option 2 is true. Therefore, the answer to this question we have already seen. Option 4 was true. So here option 2 is true. The answer to this question is 2 and options 2 and 4. That is the detailed discussion of the solution of the problem from the section algebra, which is related to the properties of the minimal polynomials. I am sure that you have understood the solution of this problem. Thank you for watching the video. Please like the video and share the video with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I wish you all the best. Thank you.